a that makes f of x continuous. So to be continuous, what does it mean to be continuous? And I will write that out as CTS just because I'm lazy. To be continuous, that means that the limit as x goes to c of f of x is equal to f of c. Remember, we talked about this as the expectation for the function is the same thing as what we actually get out of the function. That's what it means for something to be continuous. So the expectation, the limit, is the same thing as what we actually get out, f of c. So to be continuous, the limit as x goes to c of f of x must be equal to f of c. However, in this case, we don't just have to worry about limits, we also have to worry about the fact that this is a piecewise function. So since it's a piecewise function, we need to make sure that both of the pieces wind up agreeing. So first question is, does the limit exist? So, well, our question here, to be continuous, the limit is, the function will be continuous if the limit as x goes to 1 of f of x is equal to f at 1. All right, so that's the case. So what is f at 1? We'll come back to the left side and the right side in just a second. So what is f at 1? Well, f at 1 is equal to 5 minus, which one do we have to use? We use x is less than or equal to 1, so we're using this guy right here. So 5 minus 2, we swap out the x for a 1, minus swap out the x for a 1 squared. 5 minus 2 minus 1. 5 minus 2 minus 1 comes out to be 2. So f of 1 comes out to be 2. Great. All right. Now, what we need to figure out is we need to figure out, does the limit exist there? So if our limit's going to exist, we've got two different sides that we're coming from, right? We're coming from the left side and we're coming from the right side. We're coming from the less than or equal and the greater than. So we've got both a left and right side that we have to make sure match up. So since we've got two different possibilities, we have to make sure the limit as x goes to 1 of f of x has to be, is the same thing as saying, right, because we have to check that both sides match, that the limit as x goes to 1 from the negative side is equal to the limit as x goes to 1 from the positive side. Now we have to make sure that they're the same, and they should, of course, both be f of x in here. Right, we're talking about f of x this whole time. So limit as x goes to 1 from the negative side. Well, actually, we already figured out what is the limit as x goes to 1 from the negative side. Well, that's going to be based off of how this guy works because he is the left side, right? X less than or equal to 1, it behaves like 5 minus 2x minus x squared. So if you're less than, you're the negative side, so it behaves just like 5 minus 2x minus x squared. So 5 minus 2x minus x squared, we already figured out what happens there. That comes out to be 2, right? Since we're behaving just on the left side, that's just like it's going towards 2. So we know that this is going to come out to be 2. So really our only question is, does this part here equal the limit as x goes to 1 from the positive side? So we are allowed to determine ax minus 1. We can't change x because that's just a variable, but a, we were supposed to determine the value of a that will make this whole thing continuous. So we know 2, because that's what the limit as x goes to 1 from the negative side, has to be equal to ax minus 1. Ax minus 1, what x are we going to? We're going to 1 from the positive side, so we just use ax minus 1. So we plug in 1 for our x minus 1. Start working that out. We've got 2 equals a minus 1. We add 1 to both sides. We have 3 equals a. So 3 must be equal to a. And if 3 is equal to a, then that means that the limit on the right side is equal to the limit on the left side, which means that the limit does exist and that the limit will come out to be 2. And since the limit comes out to be 2 and we know that f of 1 equals 2, we now see, yes, it is indeed continuous. Might be a little bit hard to understand what's going on, so it can really help to see this graphically. So let's draw a quick picture just to cement our understanding. That's how you do it technically, but it's really useful to understand what's going on intuitively as well. So our 5 minus 2x minus x squared, that would graph basically like this. And when we get to x less than or equal to 1, we jump over to the other one. Now, since it's ax minus 1, a is taking the position of the slope, right? mx plus b is how we normally graph a line. So mx minus 1 means that we are shifted down 1. We're definitely going to have a point there of down 1 on the y-axis. But our a we are allowed to choose our value of a. So what we're doing is we're effectively choosing the slope that we're going to have. So that means we get to choose some possibility for our slope. So we have any possible rotation of this line, right? So all of the different lines that could go through here with various different slopes are all the different possibilities. So the one that we have to choose to make this thing come out to be continuous is where that line matches up to where we sort of have this handoff, where we have this breakover point. So we choose the one that matches up, we choose that slope, and it continues out from here. And that way, we wind up having the breakover winds up changing to a new track, but that track starts in the same place. We've chosen the slope so that the line matches up with where the other one finished off, and it goes through. Great. All right, so that finishes up. We now have got an understanding of how to deal with piecewise functions. It's basically a question of, does the left side and right side, do the left side and right side, one-sided limits, do they match up to each other? And if we're talking about continuity, it's a question of, does the limit match what comes out of it? And sometimes it will become a question of, do the two sides match what comes out of it? All right, that finishes up for this lesson. We'll see you at Educator.com later. Bye.